So what determines the sex of the baby? And all you need to remember in this is the SRY gene, located on the distal end of the short arm of the Y chromosome. And to remember this, you need to remember this picture. Now, if this is present, it will be a male, and if this will be absent, it will be a female. And this you can understand by two examples. In Turner syndrome, the genotype is 45XO. In this, since the Y is missing, it is a female baby. Likewise, in Klinefelter syndrome, the genotype is 47XXY, and here the Y is present, and so it will be a male baby, in spite of the fact that there are two X chromosomes. Now, the second thing that you need to remember is genes which favor the testis development, and that is SOX9 gene. How do you remember this? Testis, male, and SOX. This will help you remember the genes favoring the testis development are SOX9 gene, and the genes favoring the ovary development are RSPO1 and WNT4, important for your exams. Now, what are the methods of sex determination? The sex determination can be done by karyotyping. This is the best method. Second is looking at the genitalia once the baby is born, and this is the most common method. Third is the Barr body test, and this is an obsolete method. Now, few words about the karyotyping. Now, what is karyotyping? The process by which you get the entire chromosomal picture of any individual is called karyotyping. And where do we do it from? We can do it from the blood sample. Now, if you have to do karyotyping for the fetus, for the unborn fetus, where do you do it from? You can do it from amniotic cells, or you can do from the chorionic villus sample. So as I told you, this karyotyping gives you the entire chromosomal picture of an individual. So if the Y chromosome is present, it will be a male, and if this Y chromosome is absent, it will be a female. So normally if we do karyotyping for human beings, we can see that there are 22 pair of autosomes and 1 pair of sex chromosome, that is either XX or XY. Now here you can see a normal male karyotype. In this we have 22 pair of autosomes and 1 pair of sex chromosomes, that is X and Y. Now this karyotyping is giving you the entire chromosomal pattern of any individual. So if there is any aberration in this chromosomal pattern, you can know that by karyotyping. So what is the aberration in the chromosomal pattern called? It is called aneuploidy. So this karyotyping is also the best method to detect aneuploidy. Now we come to the type of aneuploidies which are compatible with life. So to understand this, you need to remember that we as human beings are diploid structures. When I say this, what do I mean? I mean that we have all the chromosomes in 2 sets, or all the chromosomes are in pairs. And we have 22 pair of autosomes and 1 pair of sex chromosome, that is total of 23 pair of chromosomes. Now, instead of 2 set of chromosomes, if we have 3 set of chromosomes, then it is called, instead of diploidy, it will be called triploidy. So this is the first type of aneuploidy, triploidy. All the chromosomes are present in 3 sets, and you can see this in this picture. There are 3 sets of all the chromosomes. So the total number of chromosomes will be 23 into 3, and that is 69 chromosomes. Now, the second type of aneuploidy and the most common type of aneuploidy, this is trisomy. So don't confuse it with triploidy. Trisomy, we have 3, but what? Somy means single body. Single chromosome will be 3 in number. Instead of being in pair, it will be 3 in number. And as you can see in this example, the chromosome number 17, instead of being in pair, there are 3 chromosome number 17. So the total number of chromosomes here will be 47. It will increase by 1. Now, what are the common type of trisomies that you need to remember? Number 1, trisomy of chromosome number 21, and that is called Down syndrome. Trisomy of chromosome number 13, and that is called Tau syndrome. Trisomy of chromosome number 18, and that is called Edwards syndrome. Now, the next type of aneuploidy is monosomy. As the name suggests, mono means 1, and I told you somy, 1 single chromosome. So one chromosome will be, instead of being in pair, there will be one chromosome for that. And here you can see in this example, there is 22 pair of autosomes, but the sex chromosome, only one is present, only X is present, the Y is missing. And this is Turner syndrome. Here the total number of chromosome is 45 and the sex chromosomes are XO. So Turner syndrome is an example of monosome. Now, the second method for sex determination is looking at the genitalia. Now I told you this is the most common method, but not the best method. Why not the best method? Because we have ambiguous genitalias. What are these? When looking at the genitalia, you cannot determine the sex of the baby. They are called ambiguous genitalias, and we'll discuss about this later on. Now the third method of sex determination is looking at the Barr bodies. Now the concept that I would like to give you here is, what is Barr body? These are the inactivated X chromosomes. So in any individual in which two X chromosomes are present, one X chromosome is inactivated so that this excess of this genetic material is not transferred to the individual. And this inactivated X chromosome is seen as Barr body in the buccal smear, or in female if you take a vaginal smear, you can see this Barr bodies. So as I told you, it is the inactivated X chromosome. So the number of Barr body in any individual will be the total number of X chromosome minus 1. So if two X chromosomes are present, one will be inactivated. Or you can understand this other way around, that if you are able to see in any buccal smear, if you are able to see one Barr body, that means that individual had two X chromosomes. And if you are not able to see any Barr body, that means the individual had one X chromosome. Now let us understand this by example. In normal male, since there is only one X chromosome, so 1 minus 1, 0. So in normal male, you will not be able to see any Barr body. Likewise, in normal female, you will have one Barr body, because there are two X chromosomes in a normal female, so one will be inactivated. So there will be one Barr body in a normal female. Now let us see the exception to this rule. In Turner syndrome, the normal genotype is 45XO, and so in this there will be no Barr body because there is only one X chromosome. But we have told that if there is no Barr body, then the individual will be a normal male. But this Turner syndrome, they are phenotypically female. So this is an exception to this rule. The next is Klinefelter syndrome, and in this the genotype is 47XXY. Now in these individuals, the number of Barr body will be 2 X chromosomes minus 1, and that is 1. But we have told that if there is one Barr body, we expect them to be normal females. But these Klinefelter syndrome individuals are phenotypically males. So again, this is an exception to this rule. Therefore, it is not the best method to determine the sex. Now, few words about the gonads. These gonads, they develop from the genital ridge. We'll discuss embryology in detail later on, but here you need to remember is these gonads, they develop from the genital ridge. They are bipotential till 6 weeks of gestation. And this we already know that the differentiation depends on the SRY gene. So if they are present, it will form a male, and so the testes have to be formed. And if they are absent, then the ovaries have to be formed. And now from where do these testes form? They form from the medulla of the gonads. And the ovaries, if they have to develop, they develop from the cortex of the gonads. Now how do you remember this? Cortex is the outer tough part. So you remember it that the outer tough part forms the female. So the cortex forms the ovaries, and the medulla, the inner part, forms the testes. Now the other thing that you need to remember is till 6 weeks they are bipotential. So if the SRY gene is present, then first it will lead to the development of testes at 7 weeks of gestation. And if this SRY gene is absent, then in the next week, if the testes are not formed, then these gonads will develop into ovaries at 8 weeks of gestation. Now here I would like to add one more thing, that for the formation of proper ovaries, the SRY gene should be absent, and along with this, the 2 X chromosomes should be present. Now why I am telling you this? Because in Turner syndrome, 45XO, one X chromosome is missing, and so in these individuals the ovaries that are formed, they are streak ovaries. Now the next important thing, which is the first structure to be formed in this gonads which differentiate it to be a testis, and that is the formation of testicular cords. Now we'll revise this entire thing in one sentence. Till 6 weeks of gestation, these gonads are bipotential. Now, if the Y chromosome is present along with its SRY gene and the SOX9 gene, then at 7 weeks of gestation, the medulla of these gonads, they develop into testis. Remember this and it will solve all your questions. Likewise, if this Y chromosome is absent, so the SRY gene will be absent, and both the X chromosomes are present, and RSPO1 and WNT4 genes are present, then at 8 weeks of gestation, the cortex of these gonads, they develop into ovaries. Now about the germ cells. These germ cells, they are derived from the epiblast and they are again bipotential. And as we know, if the Y chromosome is present along with its SRY gene, then these germ cells, they differentiate into spermatogonia, and if this Y chromosome is absent, then they will develop into oogonia. Now, this is all about